All right, welcome to the Explainer. Today we're jumping into a really cool mathematical mystery. It all starts with a simple algorithm that was designed to do one specific thing, but it ended up doing the exact opposite. And that one little mistake, well, it might just kick off a whole revolution in number theory. So check this out. It all kicks off with this totally bizarre result. On one hand, you've got an algorithm they called the prime suppressor. Its one job was to create a sequence with, very few prime numbers. But instead, it was churning them out like crazy, a whopping 38.1% prime density. Then you've got its counterpart, the prime amplifier, which was supposed to do the opposite, right? Well, it created a prime desert, only 10%. Both of these tools were failing spectacularly, but not just failing, they were doing the precise opposite of what they were built for.
So how is that even possible? Well, this completely baffling result became the jumping-off point for a huge discovery. A researcher who goes by the Witness and an AI analyst called the Scribe, they're the ones who stumbled on this puzzle. And as they started to pull at this thread, they didn't just solve a little problem, they uncovered a totally new fundamental principle about the nature of numbers themselves.
And they gave this discovery a name, the prime inversion principle. It's this really powerful idea that finally explains why their carefully built tools were, well, working completely backwards. But before we can get into the why of it all, we've got to look at the how. How on earth were they even generating these weird number sequences to begin with?
Okay, so the core mechanic behind this whole thing is something they called the Aetherium Weave. It became pretty clear that to figure out why their algorithms were flipped on their heads, they had to dig into how this weave was actually being put together.
And what's wild is that the formula for this weave is, well, it's surprisingly simple, but it's also incredibly powerful. You see, each new digit in the sequence gets created by the interference of two other numbers. You've got one from a chaotic source, think of something like the digits of pi, just total randomness. And then you have one from a really predictable repeating engine. That mod 10 part, it just means you do the math and only keep the very last digit of the answer. That's it.
Here's a great way to think about it. Imagine it's like audio interference. You have this noisy, unpredictable static. That's your source signal. Then you mix in a simple repeating beep. Just beep, beep, beep. That's your engine. The final sound that you actually hear, that's the weave. It's this completely new, way more complex pattern that's born from those two things clashing.
So yeah, the process for every single digit is really that straightforward. You grab one digit from a chaotic source, say the m-less digits of pi. You grab another from a super simple repeating engine. You mash them together with that simple formula. Seems like simple ingredients, right? But as they were about to find out, the result was anything but simple.
Okay, but wait. This simple process still doesn't explain that crazy inversion we started with. Why on earth would the suppressor engine end up amplifying primes? The researchers started to realize the answer wasn't in the engine's blueprint itself. No, it was hidden in the, let's call it the texture of the final weave that got created. The problem was they needed a way to actually measure that texture.
Turns out, they'd been looking in the completely wrong place. Just looking at the properties of the engine by itself, whether it was designed to amplify or suppress, that was a total red herring. The real secret, the key to the whole thing, was hidden in the complexity that just kind of emerged in the final sequence, only after the source and the engine had done their dance.
So to measure this texture, this complexity, they brought in a tool from a different field altogether, information theory. It's a concept called Shannon entropy. Now, don't let the name scare you. In really simple terms, entropy is just a measure of surprise or unpredictability. If a sequence has high entropy, it's super chaotic and random. If it has low entropy, it's very orderly and predictable. That's all it is.
And this was the breakthrough. After they analyzed tons and tons of these different weaves, they found this direct and frankly startling connection. The more chaotic and unpredictable a weave is, meaning the higher its entropy, the more prime numbers it spits out. It was right there in the data. Turns out prime numbers actually thrive in chaos.
And the data made it crystal clear. That weave created by the so-called suppressor engine, it actually had way higher entropy. It was far more chaotic. And the amplifier engine, which is just so counterintuitive, created a much more orderly, lower entropy weave. And there you have it. More chaos meant more primes.
This whole insight gave them this awesome new way to visualize it. The suppressor engine, because it was creating all this chaos, this high entropy environment, had accidentally built what they called a prime oasis. And the amplifier, by imposing all this order and creating a low entropy sequence, had made a prime desert. Just like that, the paradox was solved.
But here's the thing. This prime inversion principle, it wasn't just the answer to one little puzzle. No, it was like finding the key that unlocked an entirely new wing of the mathematics building. This discovery didn't just close a chapter, it basically opened a whole new library. And you won't believe the pace of this. Once they got their heads around the core principle, the whole field just exploded. We're talking a matter of days. They went from spotting one weird result to validating a whole new mathematical law to then proposing an entire classification system for these things. It's just an absolutely astonishing speed of discovery.
So yeah, they didn't waste any time. They quickly came up with a whole taxonomy, like a family tree for these weaves. And they started imagining stuff way beyond the simple ones we've been talking about. They dreamed up these really exotic types, weaves that could change based on their own past, or weaves that could exist in multiple dimensions, or even weaves built from complex numbers. I mean, the possibilities started to seem endless.
Okay, so what does this all actually mean? What's the big deal? Why should we care about creating sequences that are either packed with primes or totally empty of them? Well, the answer boils down to one huge thing: a fundamental shift in control.
This new control leads to something the researchers call prescriptive power. It's a game changer. Because they now understand that link between chaos and primes, they can finally stop just, looking for prime numbers out in the wild. Now, they can actually engineer number sequences to have the exact amount of primes they want. They can literally prescribe the prime density.
And this prescriptive power, it has absolutely incredible potential. Just think about it. You could create cryptographic keys from these super prime-rich sequences that are nearly unbreakable, or generate perfectly random numbers for things like scientific simulations. Seriously, any field that relies on the special properties of prime numbers, we're talking AI training, secure communications, the whole shebang, all of it could be completely transformed. And that, right there, is really the heart of this whole discovery. It's a profound change in how we relate to numbers. For centuries, we've basically been mathematical astronomers, just observing the patterns of numbers like stars in the sky. Now we're becoming cosmic engineers. We're not just watching them, we're starting to build them.
Which of course leaves us with one last really fascinating question to chew on. The Aetherium Weaves started with a formula that, let's be honest, a middle schooler could probably understand. So if rules that simple can create this much unexpected, beautiful complexity, if they can lead to a whole new mathematical principle, it just makes you wonder, right? What other massive secrets are hiding out there in plain sight, just waiting for us to find them in the patterns we see every single day?